Hi, I'm Brian Trani, a product trainer here at Trek, and I am very excited today to introduce you to the new Madone SLR. As a roadie myself, somebody who likes to push the pace on group rides, maybe pin on a number every once in a while, this is a bike I'm very excited about. Let's get started today by introducing you to some of the people who worked on it. First, we'll start with Jordan Rusing. He's our director of road bikes, and he'll give us an introduction to the new Madone. So Jordan, this is a really exciting bike, our lightest Madone disc ever. Tell me about some of the features of this new design and the new bike.
Yeah, I mean, it's our fastest road bike that we've ever made. And to talk about fast, you always need to talk about aerodynamics. And the bike has a whole plethora of aerodynamic improvements. One of them being within the frame design, which is including this new Isoflow technology. There's also a brand new bar stem system. And not only does the bar stem, is that piece more aerodynamic, but it puts the rider in a more aerodynamic position. All told, the whole bike is about 60 seconds per hour faster, including the rider, which is a huge benefit in the aerodynamic front. We also really focused on the weight of the bike. If you're talking about race bikes, weight always matters. And the new bike is almost 300 grams lighter than the previous Madone. So it's also our lightest Madone disc that we've ever made. And we did all of that while still maintaining the amazing ride quality of Madone. It's been one of the things that the platform's been known for, is sort of an all-day, everyday race bike. And we really wanted to make sure that we're keeping that amazing ride quality.
So a minute faster, 300 grams lighter, and it's still comfortable to ride. Who are the customers that are going to be lining up for the new Madone SLR?
Yeah, I mean, Madone is really focused on speed, so any rider who's motivated by going fast is going to really love the new bike. Obviously, the first one that comes to mind is our professional teams, the men's and women's Trek Segafredo team. But for any amateur racers who are wanting to do a crit or a hilly road race, they're going to get a huge advantage with the Madone. We can also consider our riders who are trying to get their local KOMs or just wanting to drop their buddies on the group ride. And again, any rider who's really wanting to go fast, this is the bike that's going to give them the competitive advantage.
We've got a lot of bikes that make that possible, right? We've got a full lineup of quality racy bikes. What makes this Madone stand out in that family, and kind of where does it slot in?
Yeah, I mean, the hierarchy of frames that we have, or frame platforms that we have, sort of are still maintained. So new Madone, really motivated by speed. It's our fast bike, is the way we talk about it internally. Imonda still remains the lightest weight road platform that we have in our family. Domani's all about being smooth and comfortable. And then we can't leave out Checkpoint, which is sort of our do-it-all gravel bike as well. And so within that whole family of products, we sort of have a bike for every rider and every motivation.
So Jordan, you already had a great race bike in the Gen 6 Madone. The new Gen 7 Madone, there's obviously a lot of new things on it. What were your goals when you set out on this process?
Yeah, I mean, Madone's the ultimate race bike for us. So intuitively, when we sort of went through the development process, we started with our race teams. We'd sponsor a men's and women's professional team with Trek Segafredo, and we went to them and asked, how can we improve upon the Madone? Intuitively, they came back with, we'd like the bike to be faster and lighter, and still something that you can race every day. And so we really embraced those as primary project goals of the bike and set some really ambitious targets from the onset. And one of the really cool things about this whole process is that we're actually able to achieve those ambitious goals. The new bike is almost 3/4 of a pound lighter than the previous version, so 300 grams, which is a huge weight savings across the whole bike, and then some huge aero improvements beyond that. I mean, the bike itself improves aerodynamics almost 10 watts, and then if you add in the rider position improvements, you're looking at another 10 watts, so it's almost 20 watts faster than the previous bike, which is a huge addition on top of those weight savings. And then with Isoflow technology, the really cool part about that is we're able to maintain the ride quality of the previous Madone. So Isoflow is about as comfortable as an IsoSpeed system in its stiffest setting, and so it's still a bike that the racers can ride every day, all day, and sort of, again, be the ultimate race bike for the vast majority of races that they have.
It's impossible to look at the new Madone without talking about the never-before-seen Isoflow technology. The function and beauty of Isoflow play a key role in Madone's design. With that, we're going to turn to Alex Bettinghouse, the senior design engineer, and John Russell, the senior industrial designer, to talk about the development of Isoflow. So Isoflow, it grabs your attention right away. Nobody's ever seen anything like this. How did you come up with this technology?
When we met with the race team, our World Tour pros, one of the biggest things that they were passionate about was how can we make the bike lighter? And they were questioning the effective IsoSpeed. So we started to dig in more into how we can make a simpler system, a lighter weight system that still gives them everything that they would want for aerodynamics and for, especially for sprinting stiffness. We did a lot of aerodynamic testing in the wind tunnel and in computational fluid dynamics and computer modeling to try to figure out like what areas of the frame we could save the most drag and weight. And so we looked at the front of the frame, but the seat tube section is really important because there's a lot of turbulent flow and a lot of chaos going down there for the air. In general, we tried a lot of crazy things and things that are already in the market.
We explored other versions of Isoflow designs that had junctions in different points of the frame, stays that were more raked forward, stays more raked back. We explored drop stays, we explored traditional stays like a Monda, changing all sorts of proportions.
And really just weighed the benefits of all of those in a very iterative and long process. We finally came up with this unique design of Isoflow where we have this hole through the seat tube that we can use to accelerate the air around the head tube and into this low pressure zone behind the rider, just making the rider and bike more aerodynamic and faster. And then it also has this cantilevered seat tube. It really optimizes for weight, aerodynamics, and compliance. And it's a unique solution that really gets us to a lighter weight system than what we had before, which was already awesome and beats our kind of aerodynamic goals by quite a bit.
One of the biggest goals with the 7th generation of Madone was to reduce as much weight as possible. And so we looked all over the bike. How can we take the things that we've already done, the things we know works well, and simplify them? So we took out the pivot, we took out that unique flexing component, and we just integrated that into the way the frame is designed. So the frame is designed to be the flexing component. It's stiff, it's aero, it's lightweight, but it's compliant in the one way we want it to be, which is with the vertical compliance in the saddle.
The Isoflow design kind of cranks up the stiffness just a little bit in order to make a really aerodynamic and lightweight and fast sprinting bike. Where we found in the past that like the IsoSpeed is such an awesome technology is over cobbles and over rough races where, you would be better served to use a Domani, which we also make and is an awesome bike. With the 2016 Madone, when we first integrated IsoSpeed, we really just wanted something that was an aero bike that rides as well as a conventional bike, just like a Monda. We wanted to be able to have the seated compliance of a Monda, but in something that was an aerodynamic, awesome race bike. And so we pulled in IsoSpeed to solve that problem. As we developed this bike, this new awesome technology of Isoflow, we were able to kind of take out some of that added complexity of IsoSpeed. And with it, we do take out a little bit of the comfort, but we add back a performance benefit in the kind of perfect formula of weight, aerodynamics, and compliance.
The new Madone is our fastest road race bike yet. Trek aerodynamicist John Davis joins us to talk more about how Madone was improved for aerodynamics. So honestly, how much faster is this new bike?
So rider going from the old bike to the new bike and keeping the same bar size, we'll see about a 19 watt improvement in drag, so a reduction in drag. That's 19 watts at 45 kilometers per hour. And that's about equivalent to 60 seconds per hour. So a ride that would take you an hour normally would take you 59 minutes on the new bike. You get those gains no matter how fast you're riding. So it's pretty hard for me to go 45 kilometers per hour consistently. So if I bring that down to 35 kilometers per hour, we get a 59 second per hour gain. And if you bring it down to 25 kilometers per hour, that's a 58 second per hour improvement from the new bike. So no matter how fast you're riding, you're going to have the aerodynamic improvements because you're riding through air. So that 19 watt number, that's the whole system, the rider and the bike. Of that 19 watts, about 9.3 watts is coming from the bike alone, and then 9.7 watts is coming from the position change on the new bike.
So you've made a lot of changes from Gen 6 Madone to Gen 7 Madone, Isoflow probably being one of the biggest ones. But before you even got to that point, you weren't working with physical models. How did the development process work?
Yeah, the design process starts with Alex and John and I sitting down and going through just a wide range of concepts. And when we're in that kind of sketching space, we can use our computer simulations. So when we simulate air moving over the rider and the bike, that's in our CFD, or computational fluid dynamics. So we can take all those concepts and we can grade them aerodynamically or rank them and see what works, what doesn't. In the CFD, you can also see what parts of the bike are faster, and you can see if the bike is actually making the rider faster. So you can pull out what part of the system has what impact on the drag, which you can't see in the wind tunnel. You just get that one number. So that's helpful. And then in the CFD, we also include the rider from the very beginning. And that's kind of a challenge because it's computationally intensive to do so, but we think it's really important because we're always trying to minimize the whole system. Bikes don't ride themselves. You need to have somebody on the bike pedaling to actually have the drag that you're measuring. So from the beginning in the CFD, we have the rider on, and then when we have some concepts that we like, we bring them to the wind tunnel and see if our estimates were accurate. And in the wind tunnel, we have a pedaling mannequin named Manny, who is really repeatable. He doesn't move around like a human rider would, and he lets us really see what those small tweaks that we do in the wind tunnel really mean in terms of drag.
So you mentioned that you make a lot of small changes, and one of the things I noticed on the new bike is that Camtail tube shapes are still there. That's something that's been around for a few generations of Madone now. Are these the same tube shapes? Are they vastly different in some way?
Yeah, so there's new tube shapes all across the bike. We have a new generation of Camtail shapes. We've had the same template for Camtail shapes for quite a while now, and we use some of our improved computing power and software that we have. So we have optimization software, and we have a supercomputer here on campus that we can run thousands of iterations of these shapes. And so we look at aerodynamics. We're running with unsteady aerodynamics to better mimic the real world. And we can also analyze these shapes for structural efficiency and weight. And then from those thousands of shapes, we choose what are the most optimal for our use case. In this case, a really aerodynamic bike that we still want to reduce the weight on. And then we can plug those in and check how they do in the CFD in the wind tunnel.
So we were talking earlier about how Gen 7 Madone had goals of being compliant and lightweight and aero, and Isoflow does all of those things. How big a deal is Isoflow?
Isoflow was huge for getting us to the parameters that we had set out for this bike. So that was the number one thing that we saw in our early concepts is those Isoflow concepts. They really reduced the drag, and that's why we kept them all the way through to the production bike. And initially we weren't really thinking about those other benefits of Isoflow. We were just thinking about aerodynamics. There's a lot aerodynamically going on in that seat stay to seat tube junction, and if you really nail it, you can really reduce the drag. And so Isoflow is a way to direct some high energy flow into a low energy region of the bike. And that's really what we're trying to do in aerodynamics is get rid of low energy and high drag areas of the bike. So when you're riding a bike, there's a really low energy area behind you. As you pedal, you create these counter-rotating vortices. I could get into a lot of detail on this, but all you need to know is that behind you there's a really low energy region, and that creates a lot of drag. That hole, kind of right in front of that low energy area, introduces a kind of a jet of fast-moving air that reduces the drag for the whole system.
So that solves the problem of what's behind the rider, that big wake, but the first part that the wind sees on a bike is the wheel and that bar stem combo, which is quite a bit different than Gen 6. What's new with the Gen 7 Madone cockpit?
The cockpit also, the actual tops of the bar, that includes the new shapes that we came up with in our optimization. And then we did a lot of work on the stem and the spacer stack. So the stem with the bar stem and the spacer stack, they really influence the aerodynamics of the rider as well because they're upstream, obviously, of the legs that are pedaling. And if you look in the flow visualization, there's a lot of interaction of the flow coming off of that and the vortices that are created on the rider. So we did a lot of really small tweaking in our CFD and in the tunnel to optimize that shape for the rider.
And another tube that is quite a bit different looking, maybe a continued evolution of other bikes, is the down tube coming into a really tall bottom bracket. Tell me a little bit about that.
Yeah, so we really, I'm talking about the shapes and kind of the global view, but we really touched every small bit of the bike, and that bottom bracket shelf is what we call it. That's an aspect of that. So when you have a seat tube bottle and a down tube bottle, that adds a lot of drag. And so we can visualize the flow around those bottles, and bringing that bottom bracket shelf up to meet the bottom of the bottle reduced the size of that wake off that bottle and improved the drag of the whole system, the bike and the bottles and the rider.
Yeah, so we've got a fast frame, we've got a fast bar, fast wheels on there. What did you do to the rider to make them the biggest part of drag in the system, right? How'd you get them more aero?
So including the rider from the beginning helps us. Every little change that we make makes the rider a little bit faster, and then we go to the tunnel, and our final test, we also tested the narrower shifter positions. So if you keep the same bar size, your shifters will move in 3 centimeters. And this was an ergonomics decision. We tested that in the wind tunnel just to see what would happen, and it was an extra 9.5 watts on top of the 9.5 watts that the bike was contributing. So it was kind of an extra bonus. So if you want to keep your same size bar, you can get that extra 9.5 watts. But if you don't want to get your hands any narrower, you still get the 9.5 watts that the bike is giving you just by itself.
So all in, all those tiny pieces combined for a pure aero savings of 19 seconds.
19 watts.
19 watts.
Yeah.
Wow. The new Madone SLR is now our lightest Madone disc ever. Let's go back to Alex and talk about how they lightened up to the design. So one of the goals was 300 grams lighter. That was something you heard from the pro riders. How did you get there?
Yeah, we really looked at the frame from not just the frame, we looked at the system from a whole bike perspective. You're never going to ride just the frame. You're going to ride a frame